Okay, in today's session, I'm going to talk about how to solve trig equations. So this trig equation says 2 sine square x plus cos x equals 2. If you examine this equation carefully, you would have noticed that I've got a square term, I've got something x term, I've got a constant term. So this reminds us, it looks very much similar to the normal quadratic equation, which says ax squared plus bx plus c equal to 0. Alright, so if I can make the connection from the equation, from the question, to my general form of quadratic equation, then this is my destination, if I may use the word. So this is where I'm heading. I'm heading to the form of quadratic equation. Now, in order to do that, I need to realize that this is sine square x, this is cos x. So I need to do a bit of adjustment using trig identity. So I'm going to say because I'm just going to use different color. I'm going to say because sine square x plus cos square x equal to 1, therefore sine square x equals 1 minus cos square x. Then I'm going to substitute this into wherever sine square x is. In other words, instead of writing sine square x, I'm going to write down 1 minus cos square x. Alright? So I'm going to do that. I'm going to write down 2, 1 minus cos square x plus cos x. Positive 2, I'm going to move to the left-hand side, becomes negative 2 equals 0. Then I'm going to expand the bracket. I get 2, take away 2 cos square x plus cos x minus 2 equals 0. Then I get negative 2 cos square x plus cos x equal to 0 because the 2 and the minus 2 cancel. Now, usually we want our the coefficient in front of the square term to be positive. Therefore, I'm going to multiply minus 1 to every single term. In other words, minus becomes positive and positive becomes negative. So I will have 2 cos square x minus cos x equal to 0. Notice that I'm just doing algebra every single line. I'm not doing much trigonometry yet. Then common factor is cos x and cos x. I'm going to take the common factor out. I'll have cos x. I'll have 2 cos x minus 1 equal to 0. Therefore, you have cos x equal to 0 or 2 cos x minus 1 equal to 0. So you would have to ask yourself, cos when x equals what? Cos x equals 0. Then I would suggest you just draw a quick sketch of what a cos graph looks like. Then it's easy to say this one is pi on 2, this one is 3 pi on 2. So those values will produce cos equal to 0. Now here, 2 cos x equal to 1, cos x equals half. So when x equals pi on 3, cos x equals half. Now, because the domain is from 0 to 360, you need to be careful and not missing any other solutions. So you would have to ask yourself, when x equals what? Cos x equals half. We've already determined there's one solution, which is pi on 3. So from 0 to 360, we would have to see, are there any other possible solution? So if I were you, I would draw the ASTC business. Then pi on 3 is obviously in the first quadrant. Now, are any other quadrant? Half is positive, therefore it has to be in the fourth quadrant. Fourth quadrant is 2 pi minus theta, which means 2 pi minus pi on 3, which will give me 5 pi on 3. Therefore, our final answer is pi on 3, 5 pi on 3, and these two answers here. So I'm just going to write down as a final conclusion. Therefore, the final answer to this particular question is pi on 2, 3 pi on 2, pi on 3, and 5 pi on 3. All right. So let's have a look at next question. Next question says cot theta plus 4 tan theta equals 4 cosec theta. So at the moment, if you examine this every term carefully, you notice that there's no square term. So I'm not going to think about the quadratic equation at this stage. I'm going to think about the definition of each ratio. So cot is cos over sine. So cos over sine. And 4, I'm going to write down 4. Tan is sine over cos. And cosec is 1 over sine, so it's going to be 4 over sine theta. Then you notice that it's a fraction plus another fraction, and it's different denominator. Therefore, I'm going to find the common denominator. Common denominator in this case would be sine theta times cos theta. So I'll have sine theta, cos theta. I've multiplied cos theta on the bottom. I'm going to multiply cos theta on the top. Therefore, I've got cos square theta. Then I have 4 sine theta, cos theta. I multiply sine theta on the bottom. Therefore, multiply sine theta on the top. In which case, I have sine square theta. Then sine theta, cos theta. On the top would be 4 cos theta. Then you can see that denominator is the same now. Therefore, I'm just going to plus the numerator and equate both sides. Therefore, I will have cos square theta plus 4 sine square theta equals 4 cos theta. Now, this looks like a little bit like previous question now. I got cos square theta, I got sine square theta, I got cos theta. I'm just going to use apply the trig identity again. So I've got cos square theta plus 4, 1 minus cos square theta equals 4 cos theta. Then I will have cos square theta plus 4 minus 4 cos square theta equals 4 cos theta. And you will have minus 4 plus 1 minus 3 cos square theta. The positive term moved to the left hand side becomes negative term plus 4 equals 0. Therefore, as we said, we want this term to be positive. I'm going to multiply minus 1 everywhere. So I get 3 cos square theta plus 4 cos theta minus 4 equal to 0. Notice that I've got cos square theta, I got cos theta. So, and this is already in a quadratic equation forms, a square term, cos theta term, and a constant term. So I'm going to say let cos theta equals m. Then I have a very nice quadratic equation, which is 3m squared plus 4m minus 4 equal to 0. Then use what we did in chapter 1, term 1, factorize quadratic equation. I will have m plus 2, 3m minus 2 equal to 0. I will have m equals minus 2. I will have m equals 2 on 3. Now we know that the range for the cosine function is from minus 1 to 1. Therefore, we say this one is not possible. We just say invalid, shall we say? And this one, we say cos theta equals 2 on 3. Theta equals 48 degrees 11 minutes. Now, in ASTC, once again, so this one is going to be 360, the fourth quadrant. So 360 minus 48 degrees 11 minutes, we'll have 311 degrees 49 minutes. That's how you do it.